Let us perform few tasks to understand how to perform joins over multiple collections using loops and conditionals. We will not be using this approach as part of our actual application development process. We are going through this just to improvise our programming knowledge. That being said, when it comes to implementation of joins, there are different strategies. They are nothing but nested loops, sort, merge, hash join. With almost all the programming languages and database technologies, they will be using one of these three approaches to actually join multiple datasets. There might be more, but these are the most commonly used ones. When it comes to our example, we will be using nested loops approach using orders and order items. First, we will be building the dict for one dataset, which is nothing but orders. It will have the unique key, which is nothing but order ID as the key in the dict, and the value will be the corresponding value which we need for downstream processing. It all depends upon the requirements. Once we go to the requirements, we'll understand what should be there as part of the dict, which will be used to look up from the other dataset while it is being processed. Once the dict is created, iteratively we'll look up into this dict while processing the other one, which is nothing but order items in our case. Now when it comes to the actual requirement, it is nothing but to get a function get daily revenue which takes orders, order items and order status as arguments, and as output it should return dict containing order date and order revenue. If you really look at the orders and order items dataset, this is how it look like. Orders have 4 attributes: ID, date, customer ID and status. When it comes to order items, it have order item ID, order item order ID, which is nothing but order ID, then product ID, then quantity, then subtotal, and then product price. So in this case, we need this one from order items to compute the revenue on daily basis, and we need this one from orders to actually get the date part for the daily revenue. As the data is distributed between multiple datasets, we have to take care of joining these two to get the daily revenue to satisfy our requirement. In this case, we also need to get revenue considering only those orders which satisfy the status passed. So we'll be passing order status as a third argument. Using that, we should be able to compute the daily revenue only for those orders which pass the criteria. Otherwise, we should not be considering to compute the daily revenue using our orders and order items dataset. Now, when it comes to the actual implementation, let me run this to get the number of elements in order items. We have 172,198 in order items and 68,883 in orders. Now, when it comes to the implementation, first we want to create the dict on orders. So as part of this dict, we'll be having order ID as the key and the date as the value. Because we want to compute daily revenue, we have to retain that date for downstream processing. That's why the orders dict, which will be returned by this function, will contain ID, which is unique, and the corresponding date. As we iterate through orders, we are actually getting the order level details, which are nothing but ID, date, customer ID and status for each and every record. And then we are comparing status with the status that is passed. If it passes the criteria, then we are updating the dict by adding a new element into it. So as and when the criteria is passed, because the order IDs are unique, it will just keep on adding elements into this dict. By the end of it, once we invoke this, we'll get all the order IDs whose status is whatever status that is passed with corresponding dates. Let me create this function and let me actually invoke the function and pass it to list so that we can actually preview the data. So this will actually return the dict object, and items will take care of returning like object, which can be typecasted to list, and we should be able to say of colon 10 like this to get first 10 elements. The internal representation of these values as dict is different. Just to preview, I am using this approach. As this will return dict, we can actually pass the key like this. It will return the corresponding value. So either you can say of 3 like this to get the date, or you can also use get. So you can say dot get, and you can actually pass the value like this, and you should be able to get the corresponding value based on the ID that is passed, which is nothing but 3. You can also get the number of elements by using len function on top of dict directly. You can see that the dict contains 22,899 elements. Now let me actually create this variable called as orders_dict. It is of type dict, and we will be looking up into this while processing order items. How we will be looking up? So first I am processing one record. From order items, I fetched one record. Order item is of type string, which will contain one record. You can preview by saying order item here. You can see the one record. This one is order ID, we have to extract this, and then we have to look up into the dictionary which is generated here. So the way you can extract is using this approach. You can say order item dot split of comma of 1, which will return this. It is of type string to typecast to integer, so that we can look up into the orders where the IDs are of type integer. You can see here the IDs in orders dict is of type integer, and hence we have to typecast even the IDs from order items as integers. That's what is happening here. Then we can look up into the dictionary using in operator. So this is the ID from order item in orders underscore dict. If the ID exists, it will return true, otherwise it will return false. In this case, there is no entry in orders underscore dict with ID 1, that's why it is returning false, whereas this one will return true because we have an entry with ID 3. As the status is complete for order ID 3, we got this record. Now let's go through the function called as get daily revenue, which will take care of looking up into orders underscore dict while processing order items and compute daily revenue. So this we already understood. It will actually return the dictionary with IDs and corresponding dates, and then I'm initializing an empty dict to have date and corresponding revenue. When it comes to dates, dates are not unique. So as we build the daily revenue, if there is an entry already with the date as part of this dict, we have to update the corresponding value, which is nothing but revenue. If there is no entry, then we just have to insert. That is the logic which we need to implement. Before getting into that implementation, I am actually processing each order item and getting the information I am looking for. I need order ID to look up into the orders and the item subtotal so that I can compute the revenue. So for each and every record like this, you will be getting this part as well as this part. So this will return whatever I have highlighted above, the ID and the subtotal part of the order item. Now using the ID extracted from order item, we should be able to look up into orders underscore dict which contain ID and corresponding date. If the ID exists, then it will go into this if condition. Here we are saying orders underscore dict underscore date equal to orders underscore dict of order item order ID. So based upon the ID, we are looking up into the orders underscore dict, it will return the corresponding date. So in this case, if you actually look at the orders underscore sample, it have 4 records. One with order ID 4 and closed as status, then order ID 5 and complete as status, then ID 7 and complete as status, then 105 as ID and complete as status. So this will not pass the condition, and hence the orders underscore dict will not contain this record. Only it will contain these 3. They are nothing but 5 25th July, 7 25th July and 105 26th July. So orders underscore dict will contain those 3 records with 5, 7 and 105 as IDs respectively. Now as we process order item sample, these will be ignored because the IDs are 4. When it comes to this record, as the ID is 5, it will actually look up into the dict which will contain the 5 and corresponding date as 2013 July 25th, and orders underscore dict underscore date will be 2013 July 25th here. Now as you get into the if condition, we are validating whether the date already exists in the daily revenue. Daily revenue is nothing but a dict which we have initialized here. We are checking if the date exists as a key in the daily revenue. If it exists, then we are actually adding the order item subtotal to the existing corresponding value of the date, which is nothing but revenue computed thus far. If it doesn't exist, we are just adding to the dict called as daily revenue with item subtotal at the corresponding value. So in this case, as part of the first iteration, because the date 2013 July 25th doesn't exist as part of the daily revenue, this part will be executed. You will see 2013 July 25th as key and $299.98 as value. Now when it goes to this record, again it will extract this value. It will look up into the dict which is created using this data, which will contain 5, 7 and 105 along with corresponding values. As 5 exists in this, it will actually extract this value to $299.95, and this $299.95 also will be added to the daily revenue. So this will be executed second time because the date already exists as part of the daily revenue. Using the corresponding value with this logic, the order item subtotal which is retrieved as part of this order item will be added to it. Like that, it will go through all 5s and 7s. It will keep on adding to the value of the existing key, which is nothing but 2013 July 25th. When it looks up into the orders dict, the value is 2013 July 26th, which is a different date than whatever we have as part of the daily revenue. This time again, it will go to the else part. It will actually update the daily revenue with a new key 2013 July 26th with corresponding value, which is nothing but $129.99. As we have 3 records, it will go through these 2 records also, and these 2 values will be added to the existing key, which is nothing but 2013 July 26th. So by the end of it, we will be having 2 records, one with 2013 July 25th as key and the other one with 2013 July 26th as key. The record with 2013 July 25th as key will have all these values aggregated as a sum, and you will see the output. Then for 2013 July 26th, the odd item subtotals of these 3 records will be added, and you will be seeing as part of the daily revenue dict with 2013 July 26th as key. Let's run these cells and we can validate. You can see the dict contain 2 records, one with 2013 July 25th, second one with 2013 July 26th as keys, and you can see the corresponding sums here for those dates. So you can add all these item subtotals and it will be this value. There might be some rounding issues, but it will be close to this. You can add these 3 order item subtotals and it will be $429.94. So that is how the implementation is taken care when it comes to joining 2 datasets using conventional loops and conditions. We can now use the function to get daily revenue considering only complete orders for our original dataset, which is nothing but orders and odd items. You can just run this and you should be able to see the details about the revenue for each date considering only complete orders. So whatever I have explained, it have taken care against all the records in odd items, and this is what you got as output. We have 364 days worth of data in our orders and odd items tables or files, and hence you will be seeing 364 records here. You can run len command on this to actually get the number of elements in this dict. So I can actually copy this and paste it here and pass it to len. I can say len of this get daily revenue like this, and we should be able to see the output as 364. As this is dict, you can also access the revenues by passing the date as key. So in this case, let's say I want to get the revenue for 2014 July 10th. I can pass this as key and I should be able to get the corresponding revenue, which is nothing but $30,247.47. So this is how you should be able to take care of not only joins but also conditions or filters as well as aggregations by using conventional loops or conditions or both. So make sure you are comfortable with all these aspects by practicing as much as you can with the provided tasks as well as exercises so that you take your programming skills to next level. And these are all real world scenarios, and hence you will be really comfortable when it comes to the implementation as part of the projects. If Python is used as the programming language, be it a mobile application or web application or a data engineering application or even a data science application.